Alright, we're going to go through the examples to the properties of limits lesson here in this video. And so you can use all the limit properties before example 1 in order to simplify example 1. Now, using these properties, we can say that the limit as x approaches 3 of 2f of x plus 7 is the same as the limit as x goes to 3 of 2f of x plus the limit as x goes to 3 of 7, and then that's the addition property. And then using the constant multiple property, we can bring the 2 out in front, and this is going to be equal to 2 times the limit as x approaches 3 of f of x plus the limit as x approaches 3 of 7. We're told in our problem stem that the limit as x approaches 3 of f of x is 2. And so now this is going to be 2 times 2. And the limit as x approaches 3 of any constant is just that constant. And so we end up finding that the value of this limit is 11. Alright. Now, you'll find as we do this that basically the decomposition here means that when we take these limits as x approaches 3, and we know the limit values, we can just go ahead and substitute those in their respective positions in the limits that we're looking at. And so to find the limit as x goes to 3 of f of x plus x over 3g of x minus 2, I'm just going to put 2 in here for f of x. Now what happens to x as x approaches 3? It approaches 3. 3 times g of x approaches negative 3. And so this ends up being 5 over negative 11. And this last one here, we can just go ahead and substitute those values in for the respective limits. We've got 2 times 2 plus 4 times negative 3, all raised to the 2/3 power. It's going to be the value of that limit. It's going to be 4 minus 12, or negative 8, raised to the 2/3. Negative 8 raised to the 2/3 is 4. So that's our first example. Okay, let's skip ahead here to the second example in the lesson, where we're finding limits at various points graphically here, a through j. We're using the graph. Okay, so first one. Limit as x approaches negative 4 from the left. Here's negative 4. As x gets closer and closer to negative 4 from the left, what value does the function approach? Well, the function is coming from down here, and it's getting closer and closer to this value right here. Alright, so it's approaching negative 2. Alright, next one, limit as x approaches negative 4 from the right. Same idea, it's approaching here, it's getting closer and closer to this value, so it's approaching negative 2. Now, one of the properties that you learned in this lesson is that if the limit approaches the same value from both the left and right, then that's the overall limit, and that comes up here in part C. The limit as x approaches negative 4 of f of x. Since the limit from the left and the limit from the right are the same, that's going to be the limit for that. And then in part D, f of negative 4, we're actually finding the function value at negative 4. We see this dot right up here that indicates that the function value is 3. This illustrates a very important concept on limits, and that is that the limit and the function value do not always need to be the same. They can be different. Okay? Alright, let's see. Next, we've got the limit as x approaches negative 3 from the left. So now we're approaching negative 3 from the left. So we want to get on this graph over to the left of negative 3, and we're walking along it closer and closer to negative 3, and the function is getting closer and closer to negative infinity. Then we're doing the same thing from the right this time. We're approaching negative 3 from the right. So we want to get on this graph to the right of x equals negative 3 and walk along the graph towards negative 3. And there it's getting closer and closer to positive infinity. Are the limit from the left and the limit from the right the same? The answer to that question is no. And so we will say that the limit as x approaches -3 of the function does not exist. Alright, and one more, we're going as x approaches 4. So we'll go over to this side. First, we're finding the limit as x approaches 4 from the left. So here's 4. We want to hop on the graph to the left of 4, and hop on the graph right over here, and walk towards where x is 4, and the value of the function is getting closer and closer to this y value, which is 2. And part I, we're approaching 4 from the right. We're going to hop on the graph to the right and walk along the graph closer and closer to 4, and the function value is getting closer and closer to 4. And so in part J, when we ask if the limit as x approaches, what the limit as x approaches 4 of the function is, since the left-hand limit and the right-hand limit aren't the same, we will say that this limit does not exist. Alright, and that's all for the examples in this properties of limits lesson.